Welcome back to my channel. Today we have ESP8266 based Wi-Fi Deauther. All the content provided in this channel is meant only for educational purpose and use it only against your own network and devices. This project will allow you to easily perform a variety of actions to test 802.11 networks using ESP8266. First of all, let's go to this particular website. They have also listed ready to use products, so you can purchase it from their commercial website. We'll be preferring a DIY solution. So here's the website. Now go to DIY tutorial option. Inside you can find the supporting devices. So I am using Node MCU for this particular project, and my Node MCU has a FTDI chip. So I have to install the required drivers to connect my Node MCU to my PC. Next step is to download the binary file. If you are interested, you can also get the source code from GitHub. Since I am using I2C OLED, I will be selecting the DSTIKE option. Inside that I have to download the OLED binary file. Once you click download, you will get the binary file in your download folder. Next step is to flash this binary file in Node MCU. A ESP web tool is already provided in the same website. You can use that directly. Connect your Node MCU to the PC. Select the port and connect the device. Once it is successfully connected, erase the memory. Once you have successfully erased the memory, next step is to disconnect, and then you have to again connect the Node MCU to the PC. Select the port details. Now select the binary file that we have downloaded. And click program. It will take some time. After flashing the binary file, give a power reset to the Node MCU. After power reset, the OLED will start displaying some details. We'll be discussing that at the end of this video. Before that, let us check out about the circuit details. So again, going to this website, click on the display and button setup. Here you will get a variety of options depending upon the type of OLED you are planning to use and type of button switches and their connectivity. You can refer that from this page. Next one is the options available for usage. So we can interact with this particular deauthor using web interface as well as display interface. For connecting the device through web interface, we have to connect to the Wi-Fi network named as PWND using the password deauthor. After connecting to Wi-Fi network, open your browser and go to 192.168.4.1. We'll find this warning window. Please read this carefully, and you have to click on I have read this option. So there are multiple options like scan, SSID and type of attack. So I'll be describing this more in detail in the display interface option. So you can go through this website to learn more about the type of attacks. Now let us talk about the display interface option. So this is my setup here. I have connected the Node MCU to OLED using I2C, and the OLED is powered from the Node MCU itself. And 3 button switches are connected to the Node MCU. 3 switches are for action up and down. You can also connect a NeoPixel RGB LED, but I have ignored that in this particular setup. Now let's power up this unit. I have connected this to a 5-volt wall charger. As soon as you power up, it will start scanning the available Wi-Fi stations as well as hotspot, and it will launch this new menu with multiple options like scan, select, attack, packet monitor, clock and LED. You can use up and down button to navigate the multiple options available in the menu. The action button can be used for selecting particular option under the menu. The first option available is for scanning the network. Let's select that. In the scanning option, there are 3 options available. Let us scan AP and stations. So as you can see, it is automatically scanning the wireless network and it has found 5 APs and 3 stations. Now next step is to select the particular Wi-Fi network from the scan list on which we are planning to attack. For that, go back to main menu and open the select option. Under the select option, we can see multiple options like AP, stations, SSID, names, etc. And as of now, we are planning to target a particular AP. So inside the AP option, there are multiple options. You can at the time select multiple APs at the same time as well as single AP. You have to select the action button. It will mark a star. That means a particular AP has been selected for attack. Once the AP is selected for attack, go back to the main menu and then select the attack option. Inside the attack option, you will find 3 options, that is deauth, beacon and probe attack. Select the type of attacks you want to perform. You can select multiple attacks at the same time and click on the start option. As you can see, the attack has been started. You can stop the attack at any time. Next option we have is packet monitor. For that, go to main menu and select the packet monitor option. Here we can monitor the packets at multiple channels. To navigate, use up and down arrows. The last option available is clock. Here you can enable a clock display in OLED screen. For that, you need to connect a RTC hardware to Node MCU. The major functions supported are like it can scan for Wi-Fi networks and clients. It can create dozens of Wi-Fi network, that is beacon flooding. It can confuse the Wi-Fi trackers by sending fake probe requests, that is also known as probe flooding. Another function is it can disconnect selected devices by sending deauth packets, that is deauthentication attack. Among which the deauthentication attack is the main feature which can be used to disconnect devices from the Wi-Fi network. So we can conclude that this is an interesting project based on ESP8266, using which you can perform multiple types of testing in 802.11 2.4 GHz Wi-Fi network. So this is only for educational purpose. Thank you.